Okay, so thank you, Mark. Appreciate all the work that's gone into setting up this conference. I understand 600 total people across the world. I know for a fact that we have at least one person in the room here that's from Ukraine, because I talked to him earlier. I know that there's people from, well, I don't see anybody from Finland yet, by way of India or Italy, pardon me, not India. Okay, Italy. I just appreciate this opportunity to talk to you. Okay, so first thing, I have an agenda where I'm going to stay right down to the minute. At least we'll see if that happens. First, I'm Jim Christensen. I'm the Chief Innovation Officer for Aldrin Family Foundation. Somebody told me that when you get a title like that, they expect you to retire. And you know something? I'm not that far from that, but it's just way too much fun doing what I get to do. I am a former middle school science teacher. I taught in the middle school for 18 years. Now, generally what happens is I tell people that, and they say something to the effect of "God bless you," because people tend to look at middle school as an arena for chaos, and they're not very far wrong. You have students that can be very challenging, and you can have students that are different on any given day. But I like middle school. I would have stayed in middle school because I was good at it. I got a national teaching award. I was a presidential awardee for excellence in mathematics and science teaching. And what that does is it drives you out of teaching. Three things happen. Well, one is um, everybody wants you on their committee, so you're gone once a week and you're a pain to your principal. Second, parents want their kids in your class, so now you're doubly a pain because of scheduling issues. And third, you get a lot of attention, and your colleagues don't necessarily appreciate that, and so you end up leaving. You make sure you got good relationships, and you go to something else. And what I did was I went to the state level. Before I left, I'd had opportunity to go to a NASA workshop, a 2-week honors workshop at that time called the NASA Educational Workshops. And at that workshop, I had an idea for a project. And I wrote the project and started doing it right at the time that video conferencing had come along. I mean, just when video conferencing had hit. And it was a new idea, and I was kind of approaching video conferencing in a way people hadn't thought about. And all of a sudden, I'm the guy. And I was able to do a lot of different kinds of projects. Well, NASA became aware of me, and I began to think, what would I really like to have been? If I could have done, somebody said, "You can do anything, Jim." And I thought, okay, what was that? I wanted to be an astronaut. So what I did was, one thing I did was I started applying for astronaut candidacy. And second, I started trying to develop skills in video conferencing and projects that would make me attractive to NASA. When NASA looks for astronauts, there's really two big things they're looking for. One is somebody that they want to work with, that they think they can get along with and makes a good team member. And second, that brings a skill to the team that they don't have. And I thought, this educator thing, that would be a thing. And basically my tagline was, take me or somebody like me, put me on space station and let me teach lessons every day. And they actually, after a time, I was down there 5 years doing the teacher workshop, 5 summers. And then finally what they did was they bought my contract out from, at that time, the state agency, Northwest Area Education Agency up in Northwest Iowa, and put me in the Teaching from Space program office. And there, what I did was I created the procedures to do video conferencing, what we called Spaceflight Education Opportunities, from space station to classrooms. Okay, one problem. And the problem was, it looked like I was going to end up traveling to Russia for a time in order to set up a project. And it was going to be during, you'll laugh, football season. My son is going to be a freshman in high school, and he's a good athlete. And I began to think, whoa, travel and be gone, watching my son play football. And watching my son play football won. And I resigned, came back to Iowa, continued on working with NASA, did a lot of things with NASA, coordinated a number of video conferences from the space station, even as not an employee anymore. I even would travel to conferences to do it. But they kind of kept me around. The day came that had an opportunity to move down to Kennedy Space Center, and I was offered the job as being director of education at Kennedy Space Center visitor complex. And what they wanted me to do was lead the effort to design a new education center. Now, we had a great name. We had an old center called ATX, Astronaut Training Experience. And what I did was led the design of the new ATX Center, and it's got two sides. It's got ATX, where you learn to be an astronaut for 5 hours. And I'd been in the astronaut office. I know what they do. Of course, I picked out the fun stuff and the experience kinds of things. And then the other side is called Mars Base One. Okay, so anyway, I did that 3 years, project's done, the thing's built. Andy Aldrin comes along and needs an executive director. I said, geez, Andy, I really like the looks of that job, and I'm ready to slow down just a little bit. Kennedy Space Center is 24 hours a day, 7 days a week. It's just all the time you're busy. And so I came on with Andy. I'm coming up on, doggone, this week was my sixth anniversary. I missed it. The 4th, November 4th, is my 6th anniversary with Aldrin, and really enjoy that. Okay, so Aldrin Family Foundation. This was a foundation that was originally conceived by Buzz Aldrin, the second man to walk on the moon. And what he would do is he would go out to schools and talk about STEM, and then later STEAM. And he felt very strongly about the A in STEM. And he would go to these schools, and kids would get really excited about talking with him. And he'd walk out, and he felt like he wasn't having a lasting influence. So what he did was that he came up with the idea, partly in collaboration with National Geographic Society, of a Mars map, of a giant Mars map. And they created a 25-foot by 25-foot giant Mars map in collaboration with a gentleman named Jim Green, who's NASA's chief scientist at that time. And they would distribute these things, and kids would do activities on them. Then what they did was they reached out to Purdue University and hired Purdue to create some curriculum materials that go along with it. Well, a couple of years later, Buzz has asked Andy to take over the operations, and Andy reached out to me and gave me a job. And so I've been with Andy since then, and I've really appreciated that opportunity. Recently, we've added 3 new employees. We added a COO to just run operations, Quincy Moore. We added Dr. Christina Otero, who does everything I don't do. When I think about activities, I think about kids doing, and I think about teachers in classrooms with kids. And Christina, while she thinks about that, she thinks it's kind of like the science behind it, and she gets that and the standards. And it's just like she's the other half of my brain on these things, and I really appreciate that. And then we've also added Dr. Mark Wagner, who takes care of business relationships. So we've got a cool organization going on with the goal of inspiring the next generation of space explorers and entrepreneurs. That's the elevator speech. Okay, so far so good. Let's talk about the giant moon map. One of our big things that we do are maps. And we've got a giant moon map and a giant Mars map. And I feel like I'm the television weather person. I'm looking here at a beautiful green screen, and through the magic of technology, there it is in front of me. And Mark has a moon map behind him that I sent him that just fits in his wall. But what this thing does is it gives place names to a thing that's both familiar and mysterious. You know, you can look up at the moon just about any given night, and there it is, and hey, it's just common. And then again, when you think about what's on the moon, pretty mysterious, pretty uncommon. So what this moon map does is a number of things, but what I want to start out with on this is I'd like to show you a thing I do when I walk in with kids. I have a globe. This is just it's a beach ball. My old one had been around the world with me literally a number of times. I'd been to India with it 5 times, which qualifies as a long time. But if you take a ball, which I got at Walmart, and you find a ball that's about the size of Australia, That's about the size of the moon in scale. Now, this one's slightly too big. The last one I had was slightly too small. We call this close enough for government work. What you can do is you have a student hold this ball, stand them all the way over in the corner of the room, have another student roll the globe 10 times and pick it up and stand there. And what that is the actual, just roughly the scale distance between the Earth and the moon. Now, I'll tell you something. Every time I do this, I think I'm mistaken because it always surprises me how far it is. And then I tell kids, okay, take your thumb, hold it out, and stand by the moon and look at the Earth. Can you cover up? Well, actually, I start with you're standing on the Earth. Can you cover up the moon? And you can easily do that. And I say, now imagine that you're standing on the moon and doing that to the Earth, and you can do that to the Earth as well. And I try to draw that picture for kids. You know, tonight when you see the moon, cover it up and think about this distance. Now, the fun thing that we like to do is this. Oh my, the magic technology, it's disappeared. Okay, this is a tennis ball. And you can't, okay, there we go. It's a tennis ball. And what we know is light takes about 1.25 seconds to go from Earth to moon. So if you take a flashlight, shine it at the moon, and just click it, 1.25 seconds later, it gets there. Well, let's say something like, that's one small step for man. Throw the tennis ball, if it takes 1.25 seconds to get there, that's scaling the speed of light. And we like to do that and talk about, you know, moon's a long ways away. It takes 1.25 seconds for light to get there. And then we do a little conversation back and forth and throw the ball, which is always fun. The ball always ends up in some unexpected place, but it's a thing we do. Well, we come back then to the moon. Okay, I guess I've still got that moon. Let's just take a look at what we've got here. First, we have a moon map that's a geologic map of the moon. It's geologic features. So you see this pink, those are areas, those are flat areas that are primarily volcanic in nature, lava flow, pyroclastic flow. You've got different craters, and the craters are colored according to when they occurred, when there was something that smashed. There's really two things that formed the moon, and the first is smashing materials into it, and the other is this dust being blown up in the air that settles down. And then there's places where there were cracks, and there was like almost like motor oil that flows out across, is what's going on. But anyway, that's that part of the map. We have right over here a chart that tells you what each one of these colors means. Now, if you just go and start reading those, it can be very intimidating. The trick is, don't get intimidated. Look at it, find a color, start looking at that color, find out what you can about it, and then tie it to something around it. And you can just learn some really fun things off of this. Okay, another thing we've got is we've got a North Pole and South Pole insets. Another thing we have is a timeline of events that have taken place related to the moon. And one of the things on there is you're going to find a number of failed missions, which we'll talk about that a little bit later. Right here is a timeline of Earth geologic ages compared to moon geologic ages. Okay, another thing we've got, and you can hardly see this, is there's three little dots here over my finger. And on this end, here's an Earth. And those are to scale, and the distances to scale. And that's kind of a fun thing. We have an activity where we actually build a Hot Wheels track, and we build it as if that Hot Wheels track is a graph of gravitational attraction at different distances. And what you can do is you can literally drop the Hot Wheels car so it climbs out of the gravity well of Earth, travels to the moon, drops into the gravity well of the moon, and if you leave a little tail, you can get it to come all the way back. Well, that would be illustrating a free return trajectory. There's plenty of problems with that particular analogy, but there's also lots of good stuff about it. It's like, oh, I see how that works. It's really simple. well, it's not quite as simple as we make it, but here's the start. You can handle this, you can think about this, and you can eventually get to the place where the math makes sense. This is how it works. Okay, so we've done the components. Let's see, have we done all one more component we should have is right over here. We have a chart that has to do with Artemis and the different segments, the different components of Artemis. Now, of course, this map is 33.5 across. It's 15-foot top to bottom. This thing's big. It's made out of 7-ounce vinyl. You can't see it, but here in my wall, I've got one hung up, and Mark's got one on his wall. We made these things to be laid out on the floor, and you can work on them. Now, it used to be, I always told people, take your shoes off when you're going to be on it. And then one day, I'm doing a program in the late afternoon on a really warm spring day in Northwest Iowa. And I had all 8th graders. And I said, okay, everybody gather around, take off your shoes. I've never done that since. Learn something. Okay, let's continue on here. The next thing I'd like to talk a little bit about is a new thing that we're doing. And what it is we're working with Kerbal Space Program. And what we're trying to accomplish is we're looking at how can we use digital tools to help kids understand space. Kerbal Space Program is a video game where kids can build their own rockets. They can test fly these rockets. If they crash, big deal. They just build a new rocket and they fly it again. And they can do all these relatively complex things, and they can do it at a very simple level. Or, does this work or doesn't it work? Or they can literally do the calculations. The other night, I found a YouTube video where a college professor had a math class that was based on Kerbal. And as I looked at the calculations, I thought, I don't know a single thing on this page. There's nothing on this page that makes sense to me. But it was all these calculations about the orbital velocities I did. But there was all this stuff that was just way up there. And yet it was also very approachable on another level, kind of depending on where you came at it from. So what we do when we look at Kerbal was designed to be one person on a machine and building and testing and doing. Well, we look at it and we think that any project we have should contain a couple things. And one of them is we think it needs to be authentic. And the truth is there's lots of authenticity to Kerbal. The second is we think it needs to be fun and engaging. We think that kids, hey, if it's not fun, it's nothing. And but it doesn't have to be just a laugh, a minute. It needs to be something that captures curiosity. Okay, the next thing is we think the projects need to contain opportunities for kids to practice communication and collaboration skills. We think that's huge, really significant. We think that's about the hardest thing human beings do, is communicate and collaborate. The next thing is like to build projects where it balances virtual and physical. Kerbal is built around the virtual. I like to put in segments into it, components into it that are physical components. We like to look at resources beyond the classroom. We like things that are sustainable. And by that, we mean they're green, they're affordable, and they're durable. That's what that line means. And the last thing is we like high quality. Now, we could go without high quality, but something about the number 7 just looked good on that page. Okay, so right now we've got a couple really nice projects we're very excited about. And what they are is they kind of build upon each other, and they become increasingly complex. The first one is called the Satellite Mission Challenge. And the big idea is to let groups of 3 kids design a rocket and get a spacecraft into orbit. And I started thinking about, okay, what's that like? Well, there was a time when the Soviet Union was trying to get into space before the Americans, and the Soviet Union got Sputnik up there on board, an R-7 rocket or something like that. And the United States, a couple months later, got Explorer 1 up aboard a Juno rocket. But there was a process of this competition. And what we do in this particular project is we let one team be the red team and one team be the blue team. And they kind of operated under some separate rules, but the idea is get a satellite up. And one of the way we assure collaboration is we ask that each team, as they're working, maintain records of what they've done, such that they can hand their records to another team and they can replicate what's been done by the first team. Okay, the second project is called Revisit Failure. And what we do is we point kids at the timeline that's at the bottom of the moon map and say, find a mission that failed. Try to figure out what went wrong with it. See if you can replay that mission successfully using Kerbal. The next mission we've got is the Lunar Settlement Challenge. And the idea there is we ask kids to break down into teams of 3, and maybe even bigger than that. But one of the teams is going to build a model of a settlement for the moon. And then the next team is going to figure out what missions would it take to go from Earth to the moon and to actually build that thing on the moon. Here you've got this model. What would it take to actually build it? And then you ask students what team they want to be on. Do you want to be on the heavy lift team? Do you want to be on the transfer team, the lunar orbit team, the lunar landing team, the crew return team? All these different groups have to be able to perform their functions using Kerbal in order to make this thing work. Okay, Mars settlement or Mars research station, very similar kind of a project. And finally, advanced integration mission. We have a story of here we are on the moon, and we've been there for quite a while now, and we're looking for ways to exploit it, to use the resources that are here. Well, what do we do with this water? How do we make more settlements? What science would we do? Do we have telescopes? All these kinds of things. What do you want to build on the moon? Do you want to build a mining facility? Do you want to build a refining facility in orbit? Do you want to build an orbit? Do you want to build an Aldrin cycler? Those are the kinds of items that are in the advanced integrated mission. Okay, so far so good. And let's see. I said I'd start there at 2:55, so boy, am I on time. Can't believe it. Let's go on to the Mars map. This is a diagram of actually a picture of our giant Mars map. I should have thrown a green cloth over my chair so you couldn't see it. I'll come back and tell you about it. But first, what I'd like to do is just explain something that kind of boggles my mind. This is a really rough diagram of an Earth orbit around the sun. I've got this star out here. That's not what the sun looks like, but that's what was on PowerPoint, so that's what I did. And the blue line is the orbit of the Earth, which you can see is pretty close to circular. It's very close to circular, in fact, but it's not a perfect circle. And the orange line is a representation of the orbit of Mars. Now, there's a couple fun things here. The first is when Earth is here, it's at its farthest point from the sun. And when Mars is here, it's at its closest point. And when they're lined up like that, if you got on the radio and sent a signal, or if you aimed a flashlight at Mars and flashed it, it takes about 4 minutes for the radio signal or light to make that trip. At this point, I like to ask, how long did it take for the light to get to the moon? And the answer is 1.25 seconds. And now we're talking about 4 minutes. Now, if we wanted to launch to the moon or to Mars, what we would do is we'd wait for things to line up correctly, and we'd wait for Earth to be about here, and we'd wait for Mars to be anywhere from about here, boy, this is hard to do, to about here. And it's going to take about 6 to 8 months. Well, 6 to 8, let's say it's 6 months. Earth is going to travel from here to here. I wonder how the television weather people do this. This is a skill here. Anyway, it's going to take about 6 months, and the moon is going to be about, or the Earth's going to be about here. And Mars in that time is going to have traveled to about here. and it's going to take about 12 minutes for the signal to go from Mars back to Earth. So if we launch when they're lined up over here, and we land when they're here and here, 12 minutes, you land and you say, hey, we made it. 12 minutes later, congratulations. 12 minutes later, you hear that. And so what I like to do is I like to ask kids how long their lunch hour is. And usually it takes pretty close to lunch to get the message there and back. And you know something, I've been saying 12, 14. Pretty close to lunchtime to get a message back and forth. Okay, so 6 months later, the Earth has gone all the way over to the other side, right there. And Mars has gotten about to here. And now it takes about 22 minutes for the signal to go back and forth. 6 months later, the Earth is back to here. Mars is up to here. Now it's at 14 minutes. 6 months later, the Earth is here and Mars is about here. And we're back to 4 minutes. Oh, and something I should show you. What we like to do is I like to match the physical with the virtual. So what we've done is, and you can find this on our website, it's called Where is Mars? We've got where you can measure a round object and say, okay, this is the sun. Now, if you want to do it in class, here's the round object, your thumb. Because if your thumb is the size of the sun, the Earth would be 1 million times smaller. So what I did was I got some tweezers and we capture a little piece of dust out of the air. Okay, that's the Earth now. But if you wrap a string around your thumb 34.5 times, 33.5 times would be the closest perihelion, and 34.5 times would be aphelion. So about one wrap of your finger is the difference between the closest the Earth is to the sun and the farthest it is to the sun. But I've got this string and I've got a loop in it. So I have a student, I always tell them I'm looking for somebody with a thumb about the size of my thumb. And then we put out the string and we measure out and we start them orbiting. We do the same thing with Mars. Turns out that perihelion is 47 wraps of string. And so orange string, because it's it should have red string, the red planet. Yeah, this looks more like Mars to me. And then I tie a knot at 47 and I tie a knot at 57. And that's the difference between where it's closest and where it's farthest. And we can do these orbits. Now, the problem is it's not perfect because the model kind of assumes that it takes twice as long for Mars to go around the sun as Earth. Well, that's not exactly right. But, you know, it's one of those close enough for government work things at first, then you can delve farther into it. Okay, so let's take a look at this map. First thing I want to show you is this is a large surface to run robots on, let me tell you. The entire map is 33.5 feet by 15 feet, and most of it is Mars surface. And these colors are topographical in nature. So you look up here and you see Hellas Planitia here that's purple. That is one big hole in the ground. It's 8,000 meters deep below sea level. And somebody will say, well, this always comes up. Kids will say, I didn't think there were any oceans on Mars. No, sea level is it's an arbitrary location. You know, everything above this, everything below this. The actual sea level is about this kind of yellowish green right here, which actually, you know, in terms of demarcating the surface of the map, it's kind of in the middle. So that's pretty nice. So that green is below sea level. The blue is below sea level. The orange is above. The yellow is right at sea level. But you can get a look at Mars. And Mars has got some really cool big features. You get over here and you see these volcanoes, these white spots. Olympus Mons, there's 3 other right in a row. One kind of fun thing is here's volcanoes and here's a volcano right over here. And you say, oh, they're a long ways away. And then you have to realize something. You're not dealing with a flat object. Here are the three. Here's Olympus Mons and the three other volcanoes. Here's the other volcano. They're real close together when you see it as a sphere. One of the things that we do is we send out a globe that's got the texture of Mars and the texture of the moon. They're called astro reality globes. And it's fun because you can literally put your fingers on this thing and start walking along and twisting as you go and see these spots, and you can feel them. When I pick up the Mars one, if I put my thumb on Olympus Mons, my index finger falls right on Hellas Planitia, and I can feel that like nothing. Then I kind of slide my finger right here, and there's Valles Marineris, and I can do that with my eyes closed. That's kind of fun. I like for kids to be able to have that kind of experience. Okay, let's see what else is on this. Up here, we have a chart that gives comparative data between Earth and Mars. The thing that I think is the most fun is that we have comparative to the moon also. And the moon, the acceleration of the moon, the gravitational acceleration is 1.62 meters per second squared, as opposed to the Earth at 9.8 meters per second squared. Here's what's fun about that. We know how fast things fall on Earth. I was trying to figure out a way to illustrate this. And one of the things I found out was you can take an iPhone and you can take pictures of things in slow motion. Well, that's about 1/8 speed. But you know something? Moon is 1/6 speed. It starts a conversation. So what I did was I had a person hold a ball over their head and drop it on slow motion. And I'd said, this is kind of like what it's like when you drop something on the moon. And it's kind of fun. It's very interesting. Well, what's different? It's a little too slow. Well, how much too slow? Not that much too slow. You can get the idea from it. Now, I've also explored, when I was at Kennedy Space Center, one of the things we were trying to do is figure out different kinds of simulations we could build. Well, when you slope things and have things roll down a slope, they tend to accelerate at the percentage of the slope. And you can, 38% gravity on Mars. Well, you can have this slope. Anyway, you can mess with that. That's one of the things we were messing with. Okay, I kind of got off the point there. We've got the Where is Mars activity. We've got the review of the map. Oh, down here, over in the corner, right over here, we have a chart of every successful rover and lander. And it used to be, we had the pictures, the original map had the pictures of the rovers. Well, the problem was the rover was about 4,000 kilometers across in scale, and it was covering the coolest place to see. So what we did was we just put the label on the map, and we put the pictures and the information off the side in the chart. Another thing that does is, if you've got the map and it just doesn't fit in your room, hey, hold the chart under. Might make it fit. We did that on purpose. Okay. One of the things that we've done with this is we've worked with project-based learning. And this is really near and dear to me. I really like project-based learning. Incidentally, if you see me looking over the top of your head, I apologize for that. The camera's right there. My notes are up on the screen just above you. And so that's why I look like this. There's not something wrong with me. But there's a number of projects that we have that we think are just really fun. And the first one was called Home on the Moon. And what we did with Home on the Moon was that the actual origin of it was COVID. Well, the actual origin was probably 20 years ago, but the origin of Home on the Moon was COVID. And what happened was, I came home one day after I'd been averaging 1.5 flights per week for the year. And all of a sudden, I'm not going anyplace. And I'm sitting at our dining room table trying to pull my computer up there. And my wife is wondering how long I'm going to be there. And none of us knew the answer to that. And I said, geez, I might as well be on the moon. And then it occurred to me something. I need air, water, food, shelter, energy, medical, transportation, and communications. I have every one of those things available to me at my house in some form. Oh, how do these systems work? How do we get air? Well, we can open the window, but we've got an HVAC system. How do we get water? Oh, we got a plumbing system, and we get that water. That water's purified, at least in Titusville, to some degree, and comes to you. We've got air, water, food. Okay, we were ordering our food delivered at that time, and we would literally wipe off the oranges. Can't believe we did that, but we did it. We've got energy. Well, energy's magic. You just flip on the switch and the lights come on. No, how does this really work? But we went through these things, and I asked teams, and the teams I was asking was families, to consider how these systems work and understand the systems in their home. And once they understood that, to say, okay, if we were going to put this on the moon, how would it work? And then build themselves a model of what their house would look on the moon. Now, what I did was I created a storyline, and the storyline was, we have landed on the moon. We've got people living on the moon. We've got people at the North Pole, South Pole. We've got people in a space station going around the Earth, or going around the moon in a halo orbit. I gave all those things a name. We had the Armstrong Science. No, it wasn't Armstrong Science Station. I'm very aware of acronyms, and I was a middle school teacher. You got to be careful with this stuff. Anyway, I had a station on the North Pole. I had the Aldrin Logistics Station on the South Pole. I had the Collins Gateway orbiting. I said, we're to the place where we have people that are coming up as tourists to the moon. Well, what are they going to do? They want to go see Tranquility Base, where Neil and Buzz landed. And we're afraid people are going to kick dirt in the footprints. So we need somebody to be the caretaker for this place. And we need you to build a family home outpost, an FHO, and put it at this location. And you're in charge of this place. You're going to keep track of this place. And so we put out this request for proposal, and people started responding to it. I got like 100 responses. And these responses were from India and Japan and from Brazil and from Chile and Poland and then all across the United States. It was just fun. Every day I was getting email from people, or I was getting like QuickTime movies where they did a fly through of a model that they built on their kitchen table, and the families doing it. And partly I thought families, because you'll laugh at this, I wanted people to work with a diverse group. You say, families aren't diverse. Okay, tell me that, and then go do a project with your brother or your sister or your, families sometimes, because of their age difference, can be incredibly diverse in terms of their viewpoints. And it's about the viewpoints. It's not about the how are you diverse. Anyway, I got all these. Well, not long after that, I was contacted by a group called ARC Mission. And what ARC Missions does is that they take knowledge, the sum of human knowledge, and they collect it and they put it on a disk. And this disk, they've developed a system to make a disk that they say will last 1 billion years. Okay, maybe it does. Anyway, they've got this long-lasting disk, and they want to put this thing on a lander going to the moon. The Peregrine lander, built by Astrobotics from Pittsburgh, Pennsylvania, that's going to be launched on board the United Launch Alliance Vulcan rocket, scheduled for Christmas Eve of this year. Holy smokes. So I sent out a message to everybody that responded to me and said, hey, if you'll send me a PDF, 3 pages, you tell about your team, tell about you, tell about your process, tell what you came up, tell whatever you want. And we're going to send it to the moon. And I am more excited about that than you can imagine. Okay, so anyway, that was Home on the Moon. We also did We Came in Peace. The idea there was build a visitor complex, make a design for a visitor complex for landing on the moon, with the idea of honoring the people that were involved, telling the story and giving the historic context. Oh, and telling what the scientific significance was. So that was one of the projects. We had one called Let the Games Begin. We figure if you're going to go to the moon, you're going to play some games. What would be a cool game to play in 1/6 gravity? I don't think it's golf. I don't think it's basketball. I don't think it's baseball. I don't think it's European football. I think there's going to be a new game. I think somebody's going to come up with it. They're going to apply the rule of physics and 1.62 meters per second squared acceleration, come up with something cool. But the idea is, tell me the game, tell me how it runs, tell me the field, what's the pitch like, what's the equipment, what's the rules. Next one we've got is School on the Moon. And this is one where we say your class is made up of individuals whose parents live around the moon. And every 9 weeks, you spend 2 weeks at school. And the rest of the time, you're out. Okay, well, that's kind of that can get twisted around in many ways. Christina actually used School on the Moon as part of a research study and did some modifications to it. Just cool stuff. But the idea is kids are experts in school. Okay, design it. And included in that, what are you going to learn? Okay, well, anyway, that was a fun one. And then finally, plan to make history. And the idea there was recreate a mission and videotape it on the way. You can find this. So all these projects are online. You can find these things. Okay, so let's see. I'm actually a little bit ahead, despite the fact I feel like I'm just talking. Okay, the next thing we've been doing that we're very, very excited about, we've gotten into doing summer camps. Now, I couldn't really come up with a good picture for summer camp. So, because the truth is, when I go out to summer camp, it's all kids that have not signed releases to have their pictures show up someplace. So this is a picture of, we were out, my wife and I were out one evening testing water rockets and figuring out the procedures and exactly what we want to test and what we want to do. And there was a soccer team that was having a party over near us. And pretty soon this family of mom and dad and 4 kids come over and they said, "What are you doing?" "Well, we're launching rockets." "Well, can we launch rockets with you?" And I taught them how to do it. And they are all over there trying to pump up the rocket with air. But what we do for summer camp, the nominal summer camp is 2 weeks, 4 days a week, 6 hours a day. And we call it rockets and rovers. 2 hours a day, you work with rockets. Every day you build, hang on. I wish I would have put this a little closer. Every day you build a rocket. And every day you build a rocket the first day, and then every day you fly them. Well, this is a soda bottle and a cup that goes on top of it, and we're able to put a parachute. Okay, you can't hardly see that, but we also have a flight computer. We put on this, and we're able to get performance data. And what we'll do is you go out the first day, you build the thing. The next day you go out and you fly it. And we've got specific procedures you follow. And then we start giving you tasks of things we want to determine. We want to know, how much difference does it make when you change the amount of air pressure you put in? How much difference does it make when you change the amount of water that goes in it? And you collect this data. We measured both off this flight computer, and we also have what Estes Industries calls an altitrack, where you measure the angle. And partly the idea is we want to keep everybody busy. So one of the things we do is, you don't want everybody sitting around watching everybody else's rocket. You want them sitting around watching their rocket. So we put kids on launch teams of 5 people. We put 2 groups of 5 on a pad. So we've got the Alpha, Bravo, Charlie, Delta, Echo, whatever teams. And we've got Alpha, Alpha, and Alpha, Bravo. We've got 2 teams there. And so while one team is launching, the other team is prepping. And then they put on and they launch, and the other team starts prepping. They collect their data, they bring it in, they put it in a database. And the next day they take this data and they look at it and they create graphs. Funny thing, there's an awful lot of kids that say they don't really like math, but it sure is fun to see their data. Sure is fun to see their graph of what their rocket did compared to everybody else's. And it's not a competition. It's a matter of, we want to do this in such a way that anybody can exactly replicate what you've done, which is one of the standards we work towards. So anyway, there's nothing much more fun than this. One of the really fun things that happened is one of our sites, the first year we did it, was Cocoa High School down in near Cocoa Beach, Florida, which is really close to Kennedy Space Center. And happened to know that there was going to be a Falcon 9 launch that day. So here we are out launching away with our rockets, and we called a halt while we watched the countdown on our phones, and then saw Falcon 9 going up just 10 miles, 12 miles over from us, maybe a little farther, maybe 20 miles away from us. But that's fun. And what I was surprised at was the low level of understanding of what was going on with that Falcon 9, despite the fact it was launching in their literal backyard. Kids didn't necessarily know that, but they really got excited when they gained that understanding. Okay, so the next thing we do with it is we do rovers, and I don't have a rover here to show you, but we had been building what's called MyBots. We've switched over to a robot called the Lego Sprite Prime. But we do about 2 hours of activities with it each day. And what these activities center around is the idea of being able to program the robot to do particular tasks, to accomplish particular things in a precise way, and to be able to measure the precision with which it operates. You think, you code something, it's a machine, it's going to do it exactly the same way every time. Yes and no. It tries, but there's a little slippage, there's something, something happens and it doesn't end up at exactly the right place. Well, what's a reasonable percentage that you can be within? Anyway, that gets to be kind of mathematical and gets to be kind of fun, and nobody knows they're hardly doing math as they're doing this stuff. And that's pretty fun, I think. Okay, the last thing we do, we have an hour left of the day. I think you probably gathered that I think Home on the Moon's a lot of fun. And so what we do is we build a simple home on the moon, and we ask the kids to work on each one of the systems and actually build a working piece for each system. So the first day we learn about it. The second day we do the food system. And the reason we do the food system is because that's the one that's going to take the longest. And we give them a little plant growth chamber, and they plant microgreen mustard seeds. And the reason we go with mustard seeds is they grow really fast. And second, when you go and eat them, a week later, you can pull these things out and you bite them and you say, whoa, that's mustard. There's no mistaking what this is. That's kind of fun. And so we do that. And so that's our food system. The thing that I always, every year I struggle with this, and we're into this thing 3 years now. We've been buying reversible fuel cells, and they're kind of expensive. They're about $150. But anyway, we get those, and each group gets one. And the idea is you can hook this reversible fuel cell up fill it with distilled water, hook it up to a solar panel, and you have electrolysis taking place, and you get a little glass of hydrogen and oxygen. Well, that's cool. That's just fun. I like that. The kids like that. But where it becomes magical is you unhook the solar cell, you hook up a electric motor with a fan on it, and that hydrogen and oxygen feeds back into it. The byproduct is water, and the fan spins. And you say, whoa, wait a minute. That's cool. Okay, I've gotten so fascinated by that this Monday, there's a crew that's putting solar panels on my roof. I've always wanted to do it. I'm going to do it. Monday's the day. Okay, so that's what our summer camp looks like. Okay, the very last thing, and I have to just tell you, My colleague, Christina, just amazes me because Christina didn't know she was going to learn this stuff. But what she's working on is she's working on a 2-year class where kids are building CubeSats. And this happened to be a picture of the materials that we're using right now that's coming from a specific manufacturer. But what Christina's value add is that she's coming up with the individual lessons that lead you from not knowing what a satellite is to having built one and operating one. Now, there's expense with this. These things aren't cheap, although they're not incredibly expensive. The expensive part is getting them to orbit. If you can find somebody that says, oh yeah, we've got space, that's a very happy day. But it can cost a lot to get something to orbit. But we work on that. And the nice thing is we're the Aldrin Family Foundation. People know our name. You know, we're in a nice spot. So anyway, Christina's been working on this. I'm very excited about this. And I help a little bit, a very little bit on this. But Christina has just typed in, it's Twig Space that we're working with. And they're great people. I didn't know if I was supposed to mention or not. So thank you.
We just have some questions in the chat, so I just put it in.
Okay. Well, I'll tell you what, it is 3:21. I said I would go to questions at 3:23. So are there questions here that you'd like to propose to me? Otherwise, I'll tell you what you do. Later on, there you go on the screen. jim.christensen@aldrinfoundation.org is how you get a hold of me. And I almost never get to just sit and talk about what we do for an hour. You know, people's eyes glaze over. And in your cases, I see everybody's snapshot. So I don't know if your eyes are glazing. So there we go. So are there any questions?
Just have to say, Jim, you're fantastic, man. Thank you.
Ted, you're just way too kind. Ted, are you going to be in Australia?
I will be. I did have a question for you, though. I put it in chat. You've mentioned the fuel cell. What's what product are you using?
Horizon Education.
Okay, thank you.
If you send me an email, I'll give you the link to it.
I will. I'm gonna probably chat over beers there in Sydney.
These things are just cool beyond cool.
Well, Jim, our chat has been particularly active. Everybody's just giving you accolades. Great job, Jim.
You know, I'm that lucky guy that gets to do the thing that's fun. You know, and it all came from a fear of losing control of the class. Because back when I was teaching middle school, the thing that everybody gets judged on is your class quiet? Is everybody in their row? Well, I'm not a real quiet kind of a person, and I'm not very much an in the row kind of a person. So I needed to come up with ways to get kids to work with me. And I figured out that if I could just give them a job that they were good at, that they'd feel good about, that they were excited to get in my classroom. And space, everybody's excited about space. I think Mark has something that 96% of kids say they like space. You know, I guess I think that numbers might be a little bit low. I think everybody likes space. But yeah, thank you. I appreciate that. Very, very humbly appreciate that.
We have some questions in the chat about Australia and if anybody's going to be there.
Well, Ted's going to be there. Liam's going to be there. So
you want to talk a little bit about what that's about? Why are we going down there, Jim?
Okay, so what it is, it's Andy Thomas Foundation is involved in a you know what? I'm a little embarrassed to say I don't know the name of the conference.
Oh, it's the Australian Space Forum.
I just always
I just put conference in myself. Yeah, I always have to look it up.
Yeah, Australian Space Forum. But there's a particular day that I'm doing activities with kids.
At the 6th of December.
Yeah, six of
And
the
what's interesting here, this is, I think, the 16th forum, Jim. They do it every 6 months, and they always do it down in Adelaide. And this year they're bringing it up to Sydney. And maybe my horizon's a little far out there, but I'm planning for IAC in 2025.
Oh, well, that's
Right.
awesome.
So this is the ground truth here, right? Getting it all lined up. I should have been down a couple of times the last year, and I mean, Australia's going gangbusters, right? As far as really trying to figure it out, we're putting rovers up on the moon, and they really want to emulate what we've done with NASA and what we've done here in the States. Pretty exciting.
A really interesting thing they're doing is they've got there's a mining company that's out in the outback in the interior that does their mining operations pretty much robotically. Ha, sounds like the moon to me. I think they're seeing that. I've done this conference I think twice before, but both times by video conference. So I just really appreciated the invitation and the opportunity. They're taking care of the expenses. And yeah, I figured you'd be there, Ted. If you don't know Ted Tagama, Ted does really great things with plant growth in particular. Just kind of incredible stuff.
We've got to grow that stuff on the moon, right, Jim?
We're going to have to. We're going to have to. Okay. Anyone else? I should say we also, and this is Andy, I'm thinking of you when I say this. We have been involved with RTC North up in, I don't know their exact location, if it's Sunderland or Newcastle. I've been up to Sunderland a couple times now and was at Newcastle this past summer. And I understand you're just north of London. But hey, UK, Britain's kind of a small place compared to America. It all seems pretty local. So we look forward to being back. I think there's really some really cool things happening over there.
A lot is changing very quickly, although in comparison to America and the rest of the world, it is actually quite slow, and we are well behind you guys, well behind, and we've got to do a lot of work to inspire the kids. One thing I wanted to ask, if it's okay, is are there any short 5-minute videos of Buzz, Aldrin, or anyone else in the space industry, just short 5-minute videos to inspire the kids to talk about the space industry? Because we can go through YouTube and there's hundreds. We get lost in it. Do you have any particular 5-minute ones, really short ones? Just
that's the problem, and Bigfoot's on the moon in some of them is the problem with some of those things. I think we can find those. I know that Aldrin has a video, and I can't put my fingers on it just immediately. If you send me an email about that, I'll answer that. Probably.
Oh yeah, I'll write a nice long one for you and your colleague.
Andy, there's sorry, I'm going to interject. The channel for this event has a bunch of stuff that's meant for educators and students, including some shorts that I edited down myself.
Oh, fantastic.
They're kind of cool. And then two, I did a series with Spaceflight Foundation where we did 18 episodes. We interviewed people from across the industry. So astronauts, engineers, scientists, but also like spacecraft interior designers and space historians and space lawyers. And those are definitely intended for student consumption too.
Yeah, because I can put them onto my website and help, well, through you guys, say, look, here are some video chats. Please look at them, get inspired. You want to know about this, talk to these people. It's very hard when I write to you guys or write to anyone within the space industry, because I'm just an independent. I 9 times out of 10 hit the spam, or you just don't get round to me or anything like that. So when these events happen, I have to summarize like, help.
Well, one way to make sure it hits us is go on our website. There's a place where you can send a generic message, and that generic message lands with Mark and with me, and I forget who else, and our communications team. And Mark typically answers those. But yeah, hey,
No, thank you.
I see we have a hand raised, and go ahead.
Yes. My name is Marufa. I'm founder and CEO of Everest Innovation Lab in Hawaii. So about the short 5-minute video I could share. We have in Hawaiian Islands, there's one small island called Lanai. And Lanai High and Elementary School, they talked to the astronauts a few months ago. So let me share my screen here. Thank you. That was very inspiring talk.
Hey,
For a
thanks
good
very
session.
much. Okay, so I am actually getting ready to walk out the door here to go to a.
Oh,
So
Yeah,
I
it
should
is, yeah,
stop
it's a good
sharing
point. It
for
is
a
the
while.
end of the session. I don't know if we should do a 5-minute video just yet, but maybe
In a
between
few
sessions.
minutes. Yeah, just a few. Let's see. Yeah. Do you see my screen? Oh, there is an advertisement. Just a second.
I think the best thing to do might be to put the link in the chat.
3 minutes.
And we're not getting audio.
Yeah.
So yeah, if you put the link in.
Yeah,
Sure.
put the link in, and then we can have that. It'll be recorded to us. That's the event. That's the kind of event I wrote the procedures for. Is what you were seeing. But thank you. We appreciate.
Yeah, thank you too.
Yeah, that's an ARIS, amateur radio on the ISS event.
Was it?
Yeah, it shows it at the back. It's just one that's
Yep, sure.
obviously ARIS is everywhere. Which
Yeah,
is the amazing thing. You can do it. Yeah.
Yeah, when I was doing it was an all hands kind of an effort through NASA to do these things, which wasn't sustainable. But it's the first we did it. Okay, so I'm ready to close down the session, and I really appreciate everyone attending. Appreciate the really kind comments. I want to thank Christina for moderating, and I'd like to thank Mark for setting this all up. And don't hesitate to contact me. I really appreciate. Oh, I appreciate the really kind words. Okay, so good afternoon.